DNS and BIND. In this nugget, we're going to explore DNS and BIND. By understanding the concepts behind DNS and BIND, you'll understand how domain names are turned into IP addresses on the internet. We'll learn how to manually convert IP addresses to domain names and vice versa using a utility called dig, and we'll also look at what's required to set up a local name server for a domain. Let's get to work. Alright, so what is DNS and BIND, and how do they relate to each other? Well, DNS is the domain name system. And the domain name system is what's responsible for translating between IP numbers and host names. So IP numbers like 137.86.52.94. Hike. Okay. So IP numbers like that, and host names, www.cbtnuggets.com, www.redhat.com, things like that. Okay, so the computer and the routers and things like that, they like IP numbers because that makes their job of routing traffic and sending packets around the internet easier. Okay, us humans, we like host names because we can't remember those stinking numbers, right? So we like host names, and I could rattle off, 20 different host names of internet sites that I visit regularly. Okay, but I could never remember all the numbers that are associated with those host names. So DNS is what translates between these two and keeps the computers and the humans happy at the same time. Alright, so BIND is the Berkeley Internet Name System, and this is the standard DNS software for Linux, okay, and Unix computers. The packages that you need to run BIND, there's one package that's called BIND, the most current version is 9.1. BIND utils and Red Hat config bind are other packages that you'll need. Okay, so now let's just talk about some DNS concepts for a minute. That'll make the rest of our discussion easier in this nugget. Okay, so I've got this slide here with some facts on it of ways to think about DNS, and then I've got a picture on the next page, and I'm going to flop back and forth between them so you can get an idea of what I'm talking about. So think about the domain namespace structured as a tree, just like we think of our directory structure on disk structured as a tree. Okay, let me just give you a little glimpse of our domain namespace. So here is a little teeny piece of the whole domain namespace of the internet. Okay, there's com domains, edu domains, net domains, gov domains, and so on. Okay, under edu there happens to be a mit.edu domain, and then there's subdomains within that, math.mit.edu, computerscience.mit.edu, and so on. Okay, so this is what I'm talking about when I say think about the domain namespace of the internet as a tree. Okay, now each domain is a node in the tree. In our directory example, nodes in the tree would be actually directories. Okay, now every node has what are called resource records, and I'll abbreviate those RR, and those store facts about the domain. In our directory example, resource records might be like files. Okay, so resource records are associated with domains just like files are associated with the directory that they're in. Okay, now nodes or domains can have any number of children, or what we call subdomains. And the root domain is called dot, just like the root directory in our directory tree is slash. That would be the root level directory. Okay, so now let's go back to that picture again. Alright, so what we're trying to do, remember, is translate between names and IP addresses. At the most primitive, that's sort of the most basic thing that DNS does for us. Okay, so what we would say to DNS is, give us the IP address of math.mit.edu. Well, what DNS would do, or what BIND would do, is it would go through this tree. It would say, okay, you want math.mit.edu? First thing it would do is look for edu. Okay, out of this whole list of things, right? There's com, edu, net, gov, mil, biz, info, tv, and then there's all the various country ones like .uk, .de, and so on. Okay, so there's lots and lots of entries at even this top level. Okay, but it looks for the edu domain. Under edu, it searches through all those to find mit.edu, because all the other educational domains are in there. University of California, Berkeley.edu, Washington.edu, and so on. Okay, so it finds mit.edu, and then you want math.mit.edu. It goes under there, it finds that, and then under there there's a resource record, and in one of those resource records is the IP number. Okay, and it gets that IP number and it spits that back to you. So now it did the translation between math.mit.edu and this IP number. Okay, so this is a simplistic picture for a lot of reasons. Okay, this isn't exactly how names are translated to numbers, but basically you get the gist of it by looking at this picture. All right, first let's try to fathom how big this picture should be if I wrote in every single domain on the internet. Okay, even if I wrote I could write IBM.com in that size of a space, I still don't think I could fit the whole picture on this page. Okay, just at the top level, you know, there's like all the different countries and all the different classifications there, right? And then underneath those, you know, just think how many .com domains there are. Think how many .edu domains there are. And then under those, think how many domains just at IBM.com there are. Okay, or MIT.edu. Think how many domains are just there. Okay, and then they can go on further down even, right? There could be a web server at cs.mit.edu called www.cs.mit.edu. Okay, and that would be another level in this tree. Okay, so this tree that contains all this domain namespace information would be absolutely gargantuan, okay, for lack of a better word. Okay, just gigantic, right? And there's no way all of this could be stored in one place. All right, so now what I want to talk about is in practice how this stuff is stored on the internet, and then we'll look at how we can, what we can do on our local machines to make the process of resolving domain names a little bit faster. Well, the way that name resolution works in practice is that there are 13 of these what are called root name servers around the world. Their names are a.rootservers.net through m.rootservers.net. And these live all over the world. There's some in California, Virginia, Stockholm, Sweden, Tokyo, okay? And they're spread around the world, and they are like the first line of name resolution. Okay? Now, they don't store all the IP addresses and domain names themselves. Instead, what they do is they hand off requests to other name servers that they know about. Okay? And then this process continues. Those name servers hand off to other name servers until what we call an authoritative name server for the domain that we're looking for is reached. Okay? So when we go to look for math.mit.edu, then what happens is it goes to the root name servers. Those name servers pass off the request to some other name server, until we get an authoritative name server for the mit.edu domain. Okay? Now, each domain has what's called a master name server, and it also has what we call slave name servers as well. They have the same information on them. All we're trying to do by having master name servers and slave name servers for a particular domain is spread out the load of name resolution. Okay, we don't want one machine handling all the name resolution for a large domain like Microsoft.com or Yahoo.com or IBM.com. These domains are really large and they have lots and lots and lots of subdomains, so having one server handle that would be bad. So that's why we have master name servers and slave name servers for each domain. Okay, so that's kind of the way that this works. That tree picture that we were looking at before is really distributed all over the internet. Okay, and then the root name servers spread that load out. They ask other name servers, and eventually some authoritative name server can actually answer the question. Okay, so let's look at some configuration files, sort of the first configuration files for DNS. Okay, there's a file called nsswitch.conf, and that's in the etc directory. Actually, all of these are in the etc directory. And this file tells the system where to look for host information. We'll look at a sample nsswitch.conf when we go out to the Linux screen. Etc hosts list computers on your network. Okay, so this is a good way to resolve IP addresses and names for local stuff. Okay, that's going to be done here. It's never going to leave your local network to resolve IP addresses and names for local stuff, because it's going to look in etc hosts first. Okay, etcresolve.conf contains IP addresses of known domain name servers. Okay, so when you set up your computer and you configure networking, you put in known name servers into some configuration tool, and they go into this particular configuration file in the etc directory. Okay, so we'll look at how all these three interplay when we go out to the Linux screen now. So let's just take a look at some of these configuration files. The first one I want to look at is the nsswitch configuration file. And what we're looking for in this file is the line that starts with hosts. Okay, now what this is telling us is that the first place that we should try to resolve host names is by looking at local files. Okay, one of the local files that we'll look at is the etc hosts file. Okay, so what we're trying to do is we're trying to save ourselves from having to go out and look at the name servers and go through that whole hierarchy to resolve a name that is actually local to our domain. Okay, so that's why files is first. Then there's NIS plus, and we'll talk about NIS in a few nuggets down the road, but that's another way that we can resolve the names, the host names. And then the final step here is use DNS. Okay, so this would amount to going out to the name server and looking at things like we were talking about, going through the tree and having one name server pass it on to another name server until you find the authoritative name server. Okay, so that's the order that we should try to resolve host names, and this is all done in such a way so that we try to minimize the amount of time that we go out on the network and have to resolve them that way. We try to resolve them locally first. Okay, so that being said, if you look at the etc hosts file, then that will contain a listing for all of your local machines on your local domain. You can see for me, I just have one entry in here for my local machine for the nugget machine here. Okay, but if I had a whole domain of machines, there would be a list in etc hosts of all of those various machines. Okay, now if my domain had thousands and thousands of machines in it, I probably wouldn't list them all in etc hosts, and instead I would let my local DNS server sort of take care of that instead of having the system look through etc hosts each time and it be like thousands of lines long. Okay, it's going to be more efficient at that point to actually look through your local DNS server for that information. Okay, so that's the etc host file, and you remember the resolve.conf file, we looked at that back in the introductory videos. All that contains is an IP address for my name server. Okay, so that's the way those configuration files are set up. Now let's take a look at a command called dig that's going to help us track down and sort of understand this process a little bit better. Alright, so now let's look at this command called dig. Now before we actually do this, I just want to explain what dig is all about. Dig is a way to look up and do a manual conversion from a host name to an IP address. You can also go backwards, and I'll show you how to do that. Put in an IP address and you'll get a host name out of it. Okay, now the reason this is so useful is that you can track down problems with DNS using dig. Okay, and dig has lots of command options. We're going to look at a few here to do some useful stuff, but there's a lot more to it. If you ever need to track down some DNS problem, dig into dig, okay, and look at the info pages and the man pages on dig to learn about even more of the options to track down even more detailed problems. Okay, the first thing I'm going to do is just type dig at the command line all by itself and hit enter. Okay, now some stuff scrolled up the screen. I'm just going to scroll back here to see what it said. Okay, so the first thing's up here. It gave some flags. We're not going to talk about what those flags mean, but if you look at the man pages for dig, it'll tell you what all of those things mean. Okay, it says we made one query and we got 13 answers. Okay. Good. Now what were those answers? Here's the answer section, and there's 13 answers listed here. And those 13 answers for the basic dig command were those 13 root name servers that we were talking about that exist all over the world. Okay, and they're all jarbled up here, but like basically it's like A through M.rootservers.net, like we were saying. Okay, now one thing here that I want to point out is that it's getting this from the NS resource record. So before we were talking about those resource records that are associated with particular directories or particular nodes in that directory, in that big tree that we were talking about. Well, that top level tree, okay, that dot node, okay, that stood for the root level of the domain name tree, has resource records, and in the NS resource record were listed all of these root servers. Okay, now let's go down here to this additional section. Well, in this additional section, it's coming out and it's saying, okay, well, this particular server, c.rootservers.net, has also an IP address, and that's listed in the A resource record for that server. Okay, so this server has some node in that big picture, that big tree that we were talking about, and the resource record that's named A has the IP address. Okay, so resource records that are named NS have the name server in them. Okay, have the actual host name in them. The resource records that are named A have the IP address in them. Okay, so that's why it's saying it got this information in the A resource record, and here's the information that it got out of that resource record, and that's the IP address for that server. Okay, so that's one thing that we can do with dig, is just look at where all the root servers are on the internet. Okay, another thing that we can do with dig is look up a particular domain name. So here I can just type in www.fasano.net, which is my personal homepage. Okay, so I'm going to hit enter here, and this is going to come up with some information. Again, it says one query, and it got one answer. Okay, the answer that it got said that www.fasano.net, okay, is this IP address. Okay, where was it getting that? It was getting that from the A resource record in the fasano.net node. Okay, and the A resource record contains the IP address for that node. Okay, and there's the IP address for the node. Okay, now notice down here there's this authority section and this additional section. The authority section says, well, okay, fine, this is the answer that it gave me, but this is who vouched for that answer. Okay, and the name servers that vouch for that answer was dns5.easy.com and dns6.easy.com. Okay, they were the authorities for www.fasano.net. Okay, so it got out of those the name server. Okay, the name server field of fasano.net gave them the name servers that were valid for fasano.net, the authority. Okay, the additional section here just resolves those names back to numbers. Okay, so dns5.easy.com has this IP address. Where did it get that from? It got that from the A resource record of dns5.easy.com. That gives the IP address of that particular name. Okay, is this making sense now? See how it's all sort of intertwined, right? There's fasano.net that relies on this name server, and then that name server has resource records that gives its IP address. Okay, so all the information is in that tree somewhere, and you're just going to have to find it. Okay, now let's go backwards with dig. Okay, and what I want to do here is I want to take this particular number here, this dns5.easy.com. I want to take that number and turn it around and look up the name for that number. Now the way that you have to do this is it's a little bit funky. You have to actually reverse this number. Okay, not reverse the number like literally like 501.212, but reverse each section. Okay, so here what I'm going to do is I'm going to say 105.212.153.209. Okay, the reason I'm reversing this is for a similar reason as that picture that I showed you earlier had com at the top, then it had IBM under it, then it had the domain under that, underneath that. Okay, so the way that math.mit.edu showed up in that tree is first it was under edu, then it was under MIT, then it was under math. Okay, so what we're going to do here is turn this IP address around so that we can find the name that's associated with it. But when we do this, we have to also have to append on something onto this. Okay, and what we append on is in-addr.arpa. Okay, so anytime you want to do what's called a reverse lookup, okay, we're putting in the IP address and we want to get the name, you put that IP address in sort of backwards, then you append on to that .inaddress.arpa. Okay, the other thing that we have to give to the dig command is what resource record we want from this particular thing. Okay, so when it goes back to look up this thing, we want the pointer record. The pointer record contains the real name of the host to which the IP address belongs. Okay, if I didn't do that pointer record, it would basically just spit out, what this address is. Okay, it wouldn't actually resolve it back for me. Okay, because it would just be giving me the A record, and the A record of this IP address is that IP address. Okay, that's what it looks for by default, is the A record, because that's what you're normally looking for in dig. Normally you give it a name, and then you look for the A record of that name, which is the actual number. Okay, here we want to go the opposite way, so we ask for the pointer record. So let me hit enter here, and now we're going to go down, and here it says query 1, answer 1, and then here's the answer section. For this particular address, now notice it left the address just the same as I typed it in. Okay, that's how it's working. Okay, it's working. It's pretending that this is its own IP address, and it's saying for that particular address, this is the pointer record for that address, and that's the actual name. Okay, that resulted from that IP number. Okay, so DNS5.ez.com. Notice down here the authority in the additional sections. These were the authorities that vouched that that IP address matched that name. Okay, so that's the name server that I would have had to go through before I got to DNS5.ez.com. All right, so is that making sense? All this information is intertwined. There's items in that tree for all the different domain names, and then these various resource records contain different bits of information about those domains. What the name server is for the domain, what the real name is for the domain, what the IP address is for the domain. All that information is in the resource records for each domain, and you can use dig to find out any of that information. So let's pull up a web browser here, and I want to walk you through this document that you would use if you were actually going to set up DNS for your local domain. Okay, let's go to the Linux search in Google, and what we're going to search for here is bind9 ARM. Okay, and ARM stands for the Administrator Reference Manual, and bind9. 9 is the version of bind that we're using. Okay, so this reference manual here is the authority for bind. Okay, and what I want to do here is just sort of give you a little tour of this particular reference manual so that you can navigate through it a little bit more easily if you're looking for certain information, get you familiar with some more of the terms that are used here. Okay, so we've already talked about DNS fundamentals and domains and domain names. The idea here is that I want to get across now is zones. Okay, so domains and domain names, we understand that. There's like mit.edu, and then within that there's math.mit.edu, cs.mit.edu, and so on. Okay, but a zone is what's actually the segment or the chunk that some server has the authority over. Okay, so when you go to configure DNS on your machine, depending on what you're doing with it, you're going to have to create a zone file that's going to say what all of the machines that you have authority over are. Okay, that way when you go to do a search like we just did with dig, or when the search is done automatically, like when I type in a web address up here into this browser, what happens is it goes out on the internet, goes through until it finds that authority. Well, the reason it found that authority, the reason that that computer was deemed the authority, is because it had a zone file that had the address that we were looking for inside of it. Okay, so once that is found, once the zone file is found, then the search stops and then the answer is returned to us. Okay, so there are two basic kinds of name servers that you can set up for your system. You can either set up one of these authoritative name servers, or you can set up a caching name server. Now, depending on how big your installation is, setting up an authoritative name server might not be required. Okay, like for Fasano.net, for instance, okay, that particular machine is just, somebody hosts that for me, and they take care of all that. I don't need to set up an authoritative name server on Fasano.net because I don't have like hundreds of subdomains there, and I don't need to take care of that myself. My hoster takes care of that for me. Okay, so that's one thing. So you set up authoritative name servers if you have an installation with lots and lots of domains in it and lots of machines in it. Okay, a caching name server you can set up even if you're not going to set up an authoritative name server. A caching name server, what that would do is that would allow repeat queries from your particular domain to be satisfied without going out onto the internet. Okay, so a caching name server would just take care of, so if I search for something like www.cbtnuggets.com and I get back that IP address, and then the web page comes up when I type it in the browser. Okay, well then if somebody next to me that's also in my domain types www.cbtnuggets.com up inside of their browser window, then they won't have to go out and get that same information that I did, because if I have a caching name server running, then they will get it from the cache. That'll be the first place that's looked before it goes out to that to the big DNS world. Okay, to that distributed tree that's distributed all over the internet. Okay, so that's the idea of a caching name server, and that will come in handy if you have quite a large domain and there's lots of people surfing the internet, right? There's lots of people that are going to go look at CNN.com over the course of a day, or Microsoft.com, or Yahoo.com, or Hotmail.com, or whatever, and having a caching name server will save repeated requests for those particular domains. So another thing I want to show you in this manual before we wrap up here is under name server configuration, there are some sample configurations that you can look at. So if you want to set up a caching only name server, they have an example there of setting up a caching only name server. If you're going to set up an authoritative name server, they have an example there. Okay. Now, one thing that you have to think about with regards to Red Hat Linux is that when you look at the etc directory, okay, there are going to be two files in there. Let me just list those files that start with name. Okay. There's named.conf and named.custom. Okay. These are these are like a team of configuration files. Named.conf is what's generated when you type Red Hat config bind. Okay, and when you type that, those changes that you make in that GUI interface are going to go into named.conf. Any changes that you need to make otherwise, like if you see something in this particular example that you need to set, but there is no setting in the GUI interface for Red Hat Linux, then what you do is you add those to named.custom. Okay, so that's a way that Red Hat differs from other Linux and Unix implementations of bind. Okay, a lot of times if you're reading a book on Linux or you're reading a book on Unix or whatever, it says, okay, change this in named.conf. Well, in Red Hat Linux, you should use the GUI tool to change named.conf, and then any other changes you need to make to named.custom. All right, well, it's time to wrap up our nugget on DNS and bind. We started by talking about how DNS works, and I tried to relate the idea of storing domain names to that of a directory tree. Okay, and that tree that we can use to store domain names is really large, but it ends up getting distributed all over the internet. Okay, so there's lots and lots of name servers all over the internet that are responsible for some small piece of that tree. And we talked about using dig to uncover information. We learned how to use dig to turn an IP address into a domain name, and also to go from a domain name to an IP address. We talked about zones versus domains. We're normally thinking about the internet in domains. Okay, but really bind, which we call name server software, is really thinking about the internet in terms of zones. Okay, so the domain might be IBM.com, but because that's such a large domain, it ends up getting split into multiple zones, and then when that query comes for some machine at IBM.com, that name server query stops when it finds an authoritative name server for the zone that that particular machine lies in. Okay, we talked about caching only name servers versus authoritative name servers. Remember, caching only name servers don't actually provide any authority for your domain. They just cache requests that were made from your domain. So if from your domain you ask for www.ibm.com, that goes out, turns into an IP address, and comes back. The next time that you ask for that, if it's soon enough, it will be satisfied from the cache instead of having to go out on the internet to find that information. Okay, and an authoritative name server, remember, is the authoritative name server for the zone that you've deemed it authoritative for. And the authoritative name server has all the machines in it listed in some configuration file for it. And the Bind 9 Administrator's Reference Manual explains how to set up authoritative name servers and caching only name servers. And this is your friend. Use that manual if you're trying to set up DNS for your particular corporate or educational domain.